In today's video, I'm going to teach you how to run a simulation in Fusion 360. First, start by opening your model in Fusion 360. Make sure everything is saved and up to date so you're analyzing the latest version. If your design has multiple components, check that they're positioned as intended and that your units are correct, since simulations rely on consistent geometry and units to produce accurate results. Next, switch to the simulation workspace. You can do this from the workspace selector at the top of the interface. Moving into this workspace changes the toolset so you can prepare and analyze your model. You'll see options specific to simulation like study types, materials, constraints, and loads. Now choose a study type. Pick the one that best matches the question you want to answer. Static stress is used for understanding how your design responds to steady forces like a constant weight or clamp. Modal helps you find natural frequencies and mode shapes to avoid resonance. Thermal evaluates how heat flows through a part or assembly and the resulting temperatures. There are others as well, but the key is to select the study that aligns with your design goal. If you're unsure, static stress is a common starting point for mechanical parts. Assign materials to your components. Each material carries critical properties such as Young's modulus, Poisson's ratio, density, and thermal conductivity for heat-related studies. Open the materials dialog, pick appropriate materials from the library, and apply them to each component in the assembly. If a part is missing a material, the solver cannot compute meaningful results, so it's worth double-checking that every component has the correct assignment and units. Apply constraints and loads to replicate real-world conditions. Constraints hold parts in place or limit motion, such as fixing a face to represent a bolted connection or using a pin or slider to allow specific movement. Loads represent how the environment acts on your design. Forces, pressures, moments, bearing loads, or temperatures, depending on the study type. Place constraints where the model is actually supported and apply loads where they truly occur. Realistic boundary conditions are the single biggest factor in getting reliable results. When everything is set, click Solve to run the simulation. Depending on your setup, Fusion 360 may offer local or cloud solving. The software will generate a mesh automatically and compute the response based on your inputs. Once it completes, you'll have access to result plots like stress, displacement, safety factor, or temperature. If something looks off, revisit your materials, constraints, or loads and refine them, then solve again. That's the essence of a good simulation workflow in Fusion 360.